In this step-by-step guide, I'm going to explain how to do some basic descriptive statistics and graphics with JASP. First, we go to the three horizontal lines to open the data. Open, and then we have the four options: recent files, computer, OSF, or data library. We are going to go to computer this time. Sometimes the folder we are looking for will be here, but in this case it's not, so I'm going to browse. And it took me to the folder that I wanted. The data is here and open. So this is my data. You can see we've got one column is for ID, and we have 300 observations, which in this case, each observation is one participant. We have some nominal or categorical variables like sex, school, region, and anxiety in terms of category, not a score. And then we've got numerical variables like age, anxiety, intelligence, which are discrete numerical variables, and study hours, teaching quality, academic achievement, income, job of choice, psychological well-being, and knowledge, that are continuous variables. We also, in the anxiety category, it's categorical, but it's also ordinal. Okay, so that's the data. Now let's go into the module descriptives to do some descriptive statistics and graphics. So let's do one variable at a time first. So let's start with any of the numerical variables. So let's take intelligence. So I can either drag here or just highlight intelligence and use the arrow there. So when the variable is here, I will get some descriptive statistics. So you can see that I didn't do anything, and I already just provided some default descriptive statistics. So how many valid cases? 300. How many missing values? So perhaps in some of data sets we have values that are not there, so it will indicate if that's the case. It calculates the mean of the variable intelligence in this sample, the standard deviation, and the minimum value and the maximum value. We can add more statistics if we go to here, statistics. And we've got here in central tendency, we only have the mean, but we can add the median, and I tick here and you can see that it responds very well. There, adding the median, the mode, and the sum. Not very interested in that one, but it calculates the sum of all the values. So I'm going to take that out. And the mode, not very interested as well. Okay, so another thing that can give us is percentile values. So quartiles, it divides the sample in 4 equal parts, so in which part it will have the same number of observations. And the values that it provides here is the 25th percentile, the 50th percentile, and the 75th percentile. And basically that's what mainly what we want in one variable. Now, let's use, instead of this is a numerical variable, let's use a categorical variable. So let's use school, for example. So we highlight school and we use the arrow. Now, all these things don't make much sense for a nominal variable, but if we tick in frequency tables, which just tell us that is for nominal and ordinal variables, so we tick on that And now we've got here the names of the school. We've got these, all these are the schools, and it tells us the frequency. So how many students attend to each of these schools, at least the students in this sample. Missing values 0, total 300. So the 300 students that we have in this sample are distributed in the schools in this way. Percent gives us the number of the percentage of observations in the sample that correspond to each of these categories. Valid, that will take into account, is the same in this case because it takes into account only the valid cases, but here, because there are no missing values, then the valid and the total will be the same. And cumulative percentage is not very useful when we have nominal variables. So let's return to another numerical variable. Let's say psychological well-being. We put there, and we've got the same values as before. Now, what we may want to do is to combine the numerical variable with a nominal variable. So we can use, let's say, region, and we use this one split. So what it will do is instead of calculating the descriptive statistics for the whole sample, it will split the sample in groups according to region. So we are going to have 4 regions, and then we will have all these descriptive statistics in well-being, but for each of the regions. So put regions and go to split. And that's what we have. We have 4 regions, east, north, south, and west. Valid cases for each region, 95, 127, 46, and 32. And then we've got the descriptive statistics in each of the regions. Now, let's go to plots. Let's move again to one variable at a time. So in this case, let's consider study hours, number of hours that students are studying. We've got the descriptive statistics, but let's see plots. Now, you can choose the color palette. At the moment, JASP is offering colorblind alternative, Viridiss, ggplot2, and gray. You can choose whatever you want. And we tick in box plots. When you have only one variable, you can use box plots or you can use distribution. Scatter plots need 2 variables. So box plots. So we got here the box plot. We can tick use color palette, and we'll give a color to the figure. And we can choose, instead of having the box plot, to use a violin. So a box plot tells us something about the distribution in this sample. Violin has the same purpose, so we can use violin. Violin and box plot together don't go very well, so we either use violin or box plot, and that's it. So the violin gives us a bit more information about the shape of the distribution of the sample. Now, what I think is the best part of this is jitter element. The jitter element actually provides the raw data. So these are all the 300 observations and how they are distributed in study hours. Okay, so basically there is a concentration of values in study hours above 25, not many values between 25 and 20, and again a huge concentration of values between 20 and 15. Now, looking at the raw data is very important. In the past, people didn't report this data, but now it's very typical to report this data. We can label outliers, so JASP will tell us if there is any outlier. Doesn't seem to be any. And we can use distribution plots as well. So distribution plots will give us here is a histogram of, these are in the x-axis, we've got the study hour values and how many counts in each bin. So we've got these bars are bins of values, and in each bin of value we've got this number of people or observations. You can display the curve here, the density, the probability density, and that's basically what we want when we have one variable. Now let's use graphs for one nominal variable, let's say sex in this case. And we ticked already frequency tables, remember? So we've got the frequency here, percentage valid, which is the same because there are no missing values. And we've got a plot here, female, male, and the counts in each case. In this case, there were no other sexes in this sample. This is basically the plots we can get for nominal variables. Now let's have two variables. We can have two numericals, let's say anxiety and intelligence. Okay, so I left the ticks there, so it will JASP automatically will do what I told it to do. So here we have the descriptive statistics in each of the two variables, and we've got distribution plots for anxiety and distribution plots for intelligence, and we've got box plot for anxiety and box plot for intelligence, or sorry, not box plot, but a violin plot. Now, when we have two numerical variables, we can use scatter plots. So we tick scatter plots and we get these. This is a very interesting plot in which we've got two variables, and in the x-axis we've got anxiety and in the y-axis intelligence. These circles are the data, so we have 300 of these circles because it's one per participant. And we've got this blue line, which is a curve that fits the data. So it's not a very good one. So not very, basically we don't have a good correlation there between anxiety and intelligence. And here it provides a density for intelligence and density for anxiety. So basically is providing information about the individual variable intelligence, which is this distribution, and the individual variable anxiety, which is this distribution, and this is the distribution of both, the bivariate distribution of anxiety and intelligence. But actually this is the raw data, not the distribution, sorry. So here it has add regression line, and in this case is a smooth one. So basically it will try to fit the data as best as possible, but if we do linear, it will provide a line. So we can see how the graph changed to a line that tries to fit the data. Now also is ticked show confidence interval, or 95% confidence interval. You can change the value of the confidence interval, and this will change the gray area of the blue line. So let's say a 60% interval. We tend to use 95 usually, but that it's a different now a gray area here in the graph. And we can get rid of that, and we can get rid of the gray area. Now, regarding the densities, instead of density, we can have a histogram. So this is the graph above the scatter plot. So I put histogram instead of density, and we have a histogram here, but still have density there. So if we want to have the same, we put histogram in both. So we've got now histogram also here, or we can have none in both. And the graph reacted and changed over there. We can also remove the regression line. So we untick regression line and the blue line disappears. Okay, so let's move now to one numerical variable and split by one of the nominal variables. So let's say anxiety category. So we are going to have variable intelligence in these 4 categories. So if you see here, the descriptive statistics, we've got intelligence for people with mild anxiety, people with moderate anxiety, people with normal anxiety, and people with severe anxiety, valid cases in each of the categories, and the descriptives in each of the categories. We've got distribution plots. That's the intelligence in mild, intelligence in moderate, intelligence in normal, and intelligence with people with severe anxiety. We've got the box plots. Now we've got different colors, and these are violin plots with raw data. One thing that we can do is we can present the raw data only as well. So here is just the data, no violin, no box plot. That's another option. And basically that's it. One more thing that we can do is to have 2 of the let's move to the case of 2 nominal variables. So let's say anxiety category as a variable, and we're going to split by sex. So basically we are going to have a how people are distributed in the anxiety categories, in the 4 anxiety categories, in female and in male. So we've got, first of all, valid cases, 163 female and 137 male. And in the frequency tables, we've got now sex female and male, and we've got the statistics that we had before, but in each for female and for male. So mild, moderate, normal, severe. These are the frequencies: 34 in mild category, 22 in moderate, 104 in normal, 3 in severe. And we've got the percentages: 20.8 in mild, 13.5 in moderate, 63.8 in normal, and 1.8 in severe. No missing values. And for male, 29 people in mild, 25 moderate, 81 in normal, 2 severe, and in percentages 21.2, 18.2, 59.1, and 1.5. We've got the distribution plots. So now we've got 4 female, we've got the anxiety category, mild, moderate, normal, severe, and we've got the bar plots, and the same for male. Now with this you can do pie charts, so I'm going to tick that, but the pie charts are better to avoid. Sometimes, some cases they are okay, but sometimes they are quite misleading. So sometimes it's difficult to identify which category has more. In this case, it doesn't work too bad because it shows that normal has a greater proportion than any other category. But moderate and mild here, we don't have a very clear idea, and perhaps better idea there. So in this case, the pie chart seems to work okay, but sometimes it's very difficult to gauge the distribution within categories. Okay, the final thing to say about this is how do you save these things. For example, frequency tables. So you use this triangle here and then copy. Copies to clipboard. So now you open a Word document, for example, and then you paste. So you either put Ctrl V, and I'm going to return, or you do the right click and you use this, keep source formatting, or takes the format of the current document. So let's keep the source. So you've got the table over there. Same with graphs. So we go to, let's say, the distribution plot with the triangle, copy. So it says copy to clipboard, and then you can go to the Word document and right click and paste. So it's too big, so let's make it smaller. There it is. So here is the graph. Okay, so in this step-by-step video, we saw descriptive statistics for one variable, numerical, and one nominal variable. And then we combined two numerical variables, then one numerical with one nominal, and then two nominal variables. We also observed how to copy and paste the tables or graphs that we generated into a Word document.